Distinction of compounds. Today we have to identify glucose and fructose analytically. How to differentiate? A number of methods are there following certain background reactions. So we shall go through the test, the analytical test, and also learn about the background reactions or different considerations regarding those tests. It's here. Actually, glucose and fructose can be differentiated, or for that matter, any compound, organic compound, or even inorganic compound can be differentiated by, if it is in the solid state, we can differentiate with melting points. They are melting points. Pure state, glucose has a melting point at 86 degrees Celsius and fructose has a melting point of 95 degrees Celsius. If you get these melting points, there is an easy method of differentiation through melting point. But it's not only the test, there are a few more tests by which you can differentiate glucose and fructose. One of the tests, important tests, is reaction with bromine water. Bromine saturated in water. A saturated solution of bromine in water is known as bromine water. Now, when you add bromine water to glucose and shake it, bromine water decolorizes. Means there is some reaction. And what is the reaction we are going to take up? It is mainly an oxidation reaction. And in case of fructose, which is a ketose, of course, no reaction takes place. There is another test. With ammonium molybdate, you get a faint blue color in place of glucose. Whereas in case of fructose, you get a greenish blue color. A very good test to differentiate the two carbohydrates, glucose and fructose. And there is a definite test for separation of glucose and fructose, which is known as Selivanov's test. And when the compound may be glucose or fructose, if you want to differentiate, when it is heated along with resorcinol concentrated HCl, you get a red color like this. This is Selivanov's test. You get a color as represented here. And here it is the resorcinol. Resorcinol plus concentrated HCl make Selivanov's reagent. And you get a red test, red color. Whereas in place of glucose, you don't find any color. Optical activity, of course, is a very good test by which you can separate glucose and fructose, or you can identify glucose and fructose. Glucose is dextrorotary, that's why we call it as dextrose also, and fructose is levorotary. Now, these are not the only tests, there are several other tests also, which we shall take up a little later. Now let us see how glucose reacts with bromine water. Glucose contains an aldehyde group, bromine water is an oxidizing agent, and water saturated with bromine is known as bromine water. And this aldehyde group is changed to carboxylic group, and the acid which you get this way, or which is formed or yielded, is known as gluconic acid. You have to learn the structure of gluconic acid. And of course, HBr is formed. Then there is another test, that is ammonium molybdate test. We have to understand what is the formula of ammonium molybdate. Ammonium molybdate is well known to us because we test the anion, phosphate ion, by using ammonium molybdate solution. It is a white to greenish yellow solid and has the structure like this. There is a negative molybdate ion and two ammonium ions are attached to it as a cation. So this is ammonium molybdate. And the test is known as Hager-Gablonski test for glucose. Of course, a Polish chemist. Glucose interacts with aqueous solution of ammonium molybdate to give a blue color in neutral medium on heating. The medium has to be neutral. And next, we get an idea about what is known as Servinow's test. Of course, a biochemical test based on the principle that on heating, on treatment with concentrated HCl, ketosis dehydrate more rapidly than alkalosis. And it is because of this that you get a fructose gives a red color with resorcinol and concentrated HCl. This is resorcinol and of course a dihydric phenol. And when you mix concentrated HCl, the reagent is known as Selivanov's reagent. Well, these are not the only tests. There are several other tests also which can be applied for distinction of glucose and fructose. Tollens reagent, Ferring solution, they also differentiate because these are oxidizing agent. They also differentiate uh, glucose and fructose, that is aldosis and ketosis. That's there. Okay, I suppose you must have got the theoretical background also along with the analytical aspects for distinction of glucose and fructose. A number of questions we are confronted with very often for relating to such distinctions. Okay, thank you. I expect you to subscribe the channel, like and share also. Thank you very much.